Intro. Supported by Protocol Labs. What does our future hold? Everything has its wonders, even darkness and silence. Helen Keller. What does the future look like? How will the universe meet its end? We may never be truly certain. But science has begun to paint a stunning picture of how the future might unfold. Let's take a journey to the end of time. We will travel through time exponentially, doubling our speed every 5 seconds. The vision of the future will surely evolve as we probe for more clues. But one thing is clear, the universe has only just begun. 2019, Anthropocene Era, 2020, Anthropocene Era, 2021, Anthropocene Era, 2021. The Holocene has ended. Anthropocene Era, 2022, the Holocene has ended. Anthropocene Era, 2023, the Holocene has ended. Anthropocene Era. What we do now, and in the next few years, will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are changing. And changing fast. Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping. Earth's magnetic field flips, comet Hale-Bopp returns, drastic sea level rise, things move on this planet, 30-meter asteroid impact, Antares goes supernova, Sahara becomes tropical, constellations begin to wander, Voyager I passes nearby star, interglacial period ends, supervolcano eruption, new Hawaiian island appears, new island chains, Apollo footprints fade, Betelgeuse goes supernova, stone monuments erode, deadly gamma ray burst, Mars moon becomes a ring, Saturn's rings vanish, Antarctica melts, major asteroid impact, new supercontinent, sun increases luminosity, as it begins to run out of fuel, the sun won't simply fade away to nothing. Its core will collapse, and the extra heat this generates will cause its outer layers to expand. All plant life dies, oceans evaporate, sun becomes a white dwarf. The sun is now dead. It remains slowly cooling in the freezing temperatures of deep space. The fate of the sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night. All stars eventually will run out of fuel. Stars begin to die off, the temperature of the universe drops. Stars, one by one, in the night sky, will turn off. And there will be no more new stars created. And so the universe will end not with a bang, but with the whimper. And not in fire, but in ice. Last red dwarf stars die, degenerate era, with the death of the last sun, the age of starlight comes to an end. Degenerate era, the universe becomes a cosmic boneyard, strewn with remnants of dead stars. Our sun becomes a white dwarf, a hot, dense, shrunken stellar corpse. With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes. In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future. Over time, gravity ejects dead stars and planets from their galaxies, sending them out into the freezing void. Black dwarfs, by chance, some brown dwarfs collide and form accidental new stars. Colliding neutron stars puncture the darkness with ultra-bright supernova. Neutron star collision, colliding neutron stars puncture the darkness with ultra-bright supernova. Any surviving life forms may find refuge around aging white dwarfs. But in time, even the white dwarfs will fade and die. A black dwarf will be the final fate of those last stars. Stars become black dwarfs, white dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter. Little more than the ashes of stars, their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun. Stars take so long to reach this point, we believe there are currently no black dwarfs in the universe. Any matter that fails to escape its galaxy is sucked into a supermassive black hole at the center. Black holes swallow stray matter, living conscious systems. Degenerate era, the rotational energy of black holes becomes the last reliable source of power for any exotic future civilizations. We have a pace of life that's based on the energy available to us now. You could imagine living, conscious systems, which have a very different pace and therefore, can extend out, at least, a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal. Even if our life dies out, one could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again, for a little while. So you might have islands in time of intelligence. As the expansion of the universe accelerates, it begins to spread matter apart faster than the speed of light. Expansion of spacetime, by this point, distant galaxies and stars are receding so fast that their light has become undetectable. The secrets of the cosmos are locked away forever. Current theories predict that atoms themselves will begin to decay, destroying all remaining matter in the universe. Proton decay, proton decay, a proton, one of the fundamental building blocks of atomic matter, what makes us up, can just spontaneously fall apart. Any material that evades the pull of a black hole eventually dies away as its protons disintegrate. Proton decay is still unproven, and so this chapter of the future could look very different in light of new discoveries. The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. Black hole era, with the black dwarfs gone, there won't be a single atom of matter left. Black hole era, light and black holes, all that will remain of our once-rich cosmos will be particles of light and black holes. The black hole era begins. No planets, no stars, no lingering stellar remnants for life to cling to. Yet even now, time has only begun to tick. On the scale of a human lifetime, the universe has just emerged from the womb. Cold, dark, and empty, this is how the cosmos will spend most of its life. Our universe gives life only a brief moment to shine, a haven in time, safe from its fiery birth and icy death. The arrow of time creates a bright window in the universe's adolescence during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life, as we know it, is only possible for 1, 10 carat, 0, 1,000th, 10 carat, minus 3, 1,000th of a, 10 carat, minus 3, 1,000th of a billion, 10 carat, minus 12, 1,000th of a billion, 10 carat, minus 21, 1,000th of a billionth, 10 carat, minus 30, 1,000th of a billion, 10 carat, minus 39, 1,000th of a billionth, billion, 10 carat, minus 48, 1,000th of a billionth, billionth, 10 carat, minus 57, 1,000th of a billionth, billion, 10 carat, minus 66, 1,000th of a billionth, billion, 10 carat, minus 75, 1,000th of a billionth, billion, 10 carat, minus 84, 1,000th of a billionth, billionth of a percent. 10 carat, minus 84%. Galaxy black holes become the fundamental building block of the universe. A galaxy will basically be a supermassive black hole in the center, with smaller black holes orbiting it. Zombie galaxies filled with black holes continue to evolve. They'll eat each other, and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales we're talking about are now trillions of years, instead of thousands or millions of years. Black hole mergers, in this far-flung age, black hole mergers become the main event. Some grow to enormous sizes, possibly trillions of times the mass of our Sun. When they merge, they send out powerful gravity waves that resonate throughout the universe. Black holes can bang on spacetime like mallets on a drum. and have a very characteristic song. Imagine two black holes that have lived a long life together. At the end of their lives they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on spacetime. Space squeezes and stretches as it emanates out from these black holes, banging on the universe. Those are the gravitational waves, and are literally the sounds of space ringing, and they will travel out from these black holes at the speed of light as they ring down and coalesce into one, spinning, quiet, black hole. If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close. As it falls in, it gets faster, and it gets louder. Scientists used to think black holes were immortal, but even these will one day die. Now we're talking about timescales of unimaginable length, quadrillions of years into the future. On that timescale, even the black holes begin to evaporate. Hawking radiation. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. Black hole evaporation, they evaporate away at an increasing rate, until they vanish in a gigantic explosion. Dark energy inflates the universe. As the black holes slowly die off, the universe continues to expand, driven by a mysterious force we don't yet understand. This is the frontier of human knowledge, a frontier ripe for exploration and discovery. Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice trillions upon trillions of years from now. Dark energy. Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, whatever, there is still energy, even in the space itself. And this energy, according to Einstein, exerts a push on the universe. What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe. Almost 3/4 of the matter-energy content of the universe is this dark energy, and we don't know what it is. Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future. So, what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster, with time a runaway universe. 70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be. The future we don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future, we won't even understand our own origins, and that's why we want to know and study this subject. Discovering the true nature of dark energy could change our vision of the future dramatically. If it somehow weakens over time, the universe could collapse under gravity, a big crunch dot. Given a boost, it could tear the universe apart at the seams, a big rip dot. Black hole era. Physicists increasingly suspect that there may be multiple universes beyond our own, each with their own unique laws of physics. Some would harbor the right conditions for life. Others could collapse or be ripped apart. Others still could be far more exotic than anything we could imagine. New pieces to this puzzle are out there somewhere, waiting to be found. The forecast does seem to be for a new beginning in ever colder, ever emptier universe. But then of course we have to ask, could that end lead to a new beginning? And there are ideas, whereby what actually is the end of our universe, could in some sense, lead to the beginning of a new one. Some speculate that there may be a way to escape our universe, before entropy erases everything. We could create simulated virtual universes, or with enough energy, create another one just like our own. We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can constrict tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe facing the death of everything there is. This, perhaps, is their only possibility of escape. And this also raises a very intriguing possibility, sheer pure speculation of course, that perhaps any universe that has intelligent life in it, will create baby universes, will create lifeboats, and will proliferate child universes. Last black hole evaporates, so an evolution may take place among universes, in the multiverse. Survival of the fittest may take place. So those universes, which do not have intelligent life, are infertile, they have no children. But those universes that have mild temperatures, stars like ours, would create civilizations that could open up child universes, and they would then proliferate. The end. If there is no way to escape the universe, then entropy will march on, destroying the last remaining supermassive black holes. As the last one explodes and dies, it bathes the universe in light one last time. Black hole era. As the last one explodes and dies, it bathes the universe in light one last time. Last black hole evaporates. As the last one explodes and dies, it bathes the universe in light one last time. The end. After an unimaginable length of time, even the black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero. Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. Time becomes meaningless. For the first time in its life, time becomes meaningless. The universe will be permanent and unchanging. Time becomes meaningless. Time becomes meaningless. Entropy finally stops increasing. Time becomes meaningless because the cosmos cannot get any more disordered. Time becomes meaningless. Time becomes meaningless. Nothing happens. 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 Time becomes meaningless. F nothing happens. Time becomes meaningless. FO nothing happens. Time becomes meaningless. For nothing happens. Time becomes meaningless. For nothing happens. Time becomes meaningless. For ev nothing happens. Time becomes meaningless. For eve nothing happens. Time becomes meaningless. Forever nothing happens. Time becomes meaningless. Forever. And it keeps not happening. Time becomes meaningless. Forever. Time becomes meaningless. Forever. Time becomes meaningless. Forever. Time becomes meaningless. Forever. Everything has its wonders, even darkness and silence, and I learn, whatever state I may be in, therein to be content. Helen Keller, crafted by MAGA ENTRTAINMENT. Supported by Protocol Labs. Protocol Labs. Protocol Labs. What will you discover? Protocol Labs. What will you discover? How will you change the future? What will you discover? How will you change the future? Featuring the voices of David Attenborough, featuring the voices of Craig Childs, featuring the voices of Brian Cox, featuring the voices of Neil deGrasse Tyson, featuring the voices of Michelle Thaler, featuring the voices of Lawrence Krauss, featuring the voices of Michio Kaku, featuring the voices of Mike Rowe, featuring the voices of Phil Plait, featuring the voices of Jana Levin, featuring the voices of Stephen Hawking, featuring the voices of Sean Carroll, featuring the voices of Alex Filipenko, featuring the voices of Martin Rees. Thanks to Juan Benet and my supporters on Patreon, patreon.com/mega entertainment, melodysHep.com.